Okay, let's do kind of a fun little example here. This is example 2 out of your book on 575. Okay, so it says a research ship finds that the angle of elevation of a volcanic island peak is 25.6 degrees. After the ship is moved 1,050 meters closer to the island, the angle of elevation changes to 31.2 degrees. And we want to find the height of the peak above sea level. So let's draw a little picture here. So the angle of elevation is always measured off of a horizontal. So here's the water, and here's my little volcanic peak. And when the ship is here, okay, it sees an angle of elevation to that peak at 25.6 degrees. So this right here is 25.6 degrees. Okay, and so then the ship goes a little closer here, travels a distance of 1,050 meters, and when it hits that spot, the new angle of elevation, so measured from the horizontal, okay, so there's an angle of elevation in there. Same with this in here, right? That's the angle of elevation measured off the horizontal. Okay, it's going to be 31.2 degrees. Okay, so we've got these two little things. So what we want to do is we want to find this. Let's call it y. All right, and just for kicks here, we're going to call this distance that starts from here and ends here, we're going to call this x. Okay, so the distance it's got left to the base of the peak. So I guess the idea here is that it's not like I can drill into this volcano from the top and just run a line from the top to the bottom to see how high it is, but I can use this little trick of the angles here to find out what the actual altitude of my volcano is. All right, so let's take a look here. I've got an opposite side and an adjacent side with my angles here. So let's draw a couple, or make a couple of equations with tan. So I'm going to say that tan of 25.6, that's going to equal, okay, looks like y opposite over, and here I've got x plus 1050. Okay, so the distance from here to here, okay, is going to give me x plus 1050. So that's my y over my x, or my adjacent side. Okay, and another formula or ratio that I can draw is tan of 31.2 degrees is equal to y over, and this is just simply x. Okay, so I've got two nice equations there, but what we really want to find is we want to find y. We want to find the height of the altitude of our volcano. Okay, so we can do a little substitution here. Now, I see I want to get rid of my fractions. And here in this equation, I see kind of the ugly stuff underneath. So I'm going to do a little trick here. I'm going to change this to cotangent instead. So I'm going to say cotangent of 25.6 degrees is equal to, and that, if it's cotangent, it just means the reciprocal of what I got here. So it's going to be x plus 1050 over y. Okay, and just because it's cotangent here, I'm going to do the same to the other one, and I'm going to call this cotangent of 31.2 degrees is equal to x over y. Okay, and I want to find y, so it might be nice to solve for x here, so I have this expression in terms of y. So x is going to equal Okay, cotangent of 31.2 degrees. So in my calculator, I'm going to write that as 1 divided by tan of 31.2. And that's going to equal 1.651. And then I'm going to multiply both sides by y. Okay, so that's what x equals. So now what I can do is I can take this and I can substitute it into x. I found x by itself. Okay, so let's go ahead and put, so then this will all look like it's in terms of y, and I can go ahead and solve for y. So let's find the value of cotangent of 26.5 in the calculator. Make sure you have your calculator in degree mode here. We've been working in radians for the last couple of weeks, but yeah, we want to see this in degree mode here because that's what we're getting, degrees. So cotangent, so 1 divided by tan of 25.6 equals, so I'm going to get this equation now is going to look like 2.087 y is equal to, and now I'm going to put this 1.651 y in where the x is. So 1.651 y plus my 1050. Okay, and I got a nice equation here. So now all I need to do is go ahead and solve for y. So 2.087 y minus 1.651 equals, okay, so over here I've got 0.436y is equal to, it looks like 1050. So divide both sides now by 0.436, and what do we get? We get 2,408. Yeah, so the height of our volcano is 2,408 meters. So there's a nice little right triangle problem. We made two equations, and we kind of made a little substitution trick into here so that we could get the height. So yeah, that'll set you up for a few nice ones in the homework.